Hello everyone. In the third part, we're going to see the access list configuration, and which is used actually to control the traffic from inside network to outside network through the DMZ. First, let's go to the inside router. Now, in the inside router, we're going to have a look at the configuration file. Now, in the configuration file, we notice that we have access list configured in the fast Ethernet interfaces like this: fast Ethernet 0/0, fast Ethernet 1/0, and gigabit Ethernet 2/0, gigabit Ethernet 3/0, and gigabit Ethernet 4/0. So now let me just focus on the first one, access list 100 in the inbound direction on fast Ethernet 0/0, and I will just explain this access list. The second one will be the same as the first one, but coming from a different internal segment. So now let's go to, I would like to display access list 100. Now, through the access list 100, you notice that its access list permits ICMP traffic from any host on segment 172.16.0.0 to any host. Like this, any host on this segment will be able to ping any host from even to outside, and also it will be able to ping any host on the other internal segment. The second thing, we notice that this access list 100 will permit TCP traffic from any host on segment 172.16.0.0 to host 10.11.11.1. What is this host? It is the host actually acting as a web server or secure web server. So any TCP traffic generated from host 1, host 2, host 3 to web server will be allowed through this access list, which is applied in the inbound direction on the fast Ethernet 0/0. The same thing with the FTP server. So any host on segment 172.16.0.0 will be allowed to access the FTP server. Now, since FTP protocol is out-of-band protocol, so it requires two connections: one connection to port 21 for comment, and another connection to port 20 on the server side, of course, for data. So we have to think to allow these two kinds of TCP connections to be established between any host on the internal segments to the FTP server. The same thing here, we're going to allow TCP connections to be established from any host on internal segment 172.16.0.0 to external web server, DNS, Part3, and SMTP. These are the services configured here on the outside region of the network. Now this access list is applied in the inbound direction of the fast Ethernet 0/0. It means access list is applied to this interface, of course, in the inbound direction. So it's going to look at all packets coming into it. Now I'm not going to talk about access list 101 because it's basically the same idea. This is access list 101 and it is actually the same idea. Let me just focus on access list 110. Access list 110 is an access list which is configured on gigabit Ethernet 1/0, gigabit Ethernet 2/0, 3/0, and 4/0. So it is configured on this interface, again in the inbound direction. So it's going to look at all packets coming into it. What we have inside this access list, basically the access list is going to permit all TCP traffic from host 10.22.22.1 originating at port 20 to any host on segment 172.16.0.0 or segments 172.17.0.0. Because of course of the out-of-band nature of the FTP protocol, it's always the FTP server is going to establish a TCP connection with the requesting FTP client, and the FTP connection will be established at port 20. So like this, we have to allow that second connection, otherwise this will not work. Also, this access list permits all TCP traffic from any host to any host on segment 172.16.0.0. But you notice this keyword here. Keyword established. It means that this TCP connection should have been initiated from this internal segments 172.16.0.0 or 172.17.0.0. And what we are permitting here, we are just permitting reply TCP segments, a reply for these the initiation of the establishment of TCP connection from the inside network. Here we are just tightening the control over TCP connection. No TCP segments which is initiated outside will be allowed to go in. And the last thing here you notice, and another thing you notice, the ICMP protocol, it is allowed from any source to any host on these internal segments. But what is allowed? Only the echo reply. Only echo reply is allowed, which means that the echo request should have been initiated and generated from inside, from within the internal segments. So here we are controlling the type of ICMP packets allowed to inside network. And finally, we are permitting UDP traffic from any source to any source. Now, as you notice, like this, we have three different types of we have three different access lists applied on the inside router. Now, on the outside router, what we have done on the outside router, we have configured netting. So if you look at the configuration, you notice one thing very interesting here is that netting has been configured. So now, access list 1 is going to explicitly define which source IP address will be translated into the IP address assigned to serial interface 2/0 in overload. Here we are using the port address translation. All the source IP addresses will be translated into the IP address assigned to this interface serial 2/0. So here we rely mainly on the port address translation to achieve the function of netting. Also, we are saying something very interesting here, is that if something comes from outside to inside, if anyone from outside wants to communicate with the web server which is on the DMZ zone, which is here on the DMZ zone, right? So he's going to send the communication to IP address 196.15.60.1 at port 80. Now the NAT will translate the destination IP address into this destination IP address 10.11.11.1. So to users outside, they are not going to see exactly the exact IP address of the web server on the DMZ in the DMZ, or they will not see the IP address of the FTP server in the DMZ. But what they will see, they will only be given the public IP address of the IP address assigned to this interface of outside router. And then this outside router will do internal translation, so it will translate the destination IP address from 196.15.60.1 into the internal IP address 10.11.11.1 or 10.22.22.1. These are the IP addresses assigned to web server and FTP server respectively. And like this, we are hiding these details about IP address assignment to outside users. Not only that, you observe that we are using private IP addresses, and private IP addresses should be used only inside private networks or organization intranet, so they should not be seen from outside, and they should not leak to outside also. So an outside user will be provided only with a global, or let's say a public IP address. Now when it comes to the access list itself, so I'm going to display the access list. What is allowed actually in the access list 100, we are allowing only the packet which are sent to host 196.15.60.1. So packet from any host, which is the outside network or internet, for example, will be allowed to go to host 196.15.60.1, which is this IP address. And when they reach this IP address, now the router will be in charge of IPNet show IPNet translation. So the router will receive this packet destined for this network, for this IP address 196.15.60.1, and then it will translate them to the IP address of the relevant server, whether it is web server or the FTP server. So like this, we are protecting our internal network. No communication from outside will be allowed to go to any one of these private IP addresses that make our internal network. Only to this global IP address, to this global outside or public IP address 196.15.60.1. So the router is going to divert the traffic to the server, which is to the intended server. From outside also, from inside on the other side, from the inside, host will be able to access the servers on the DMZ side, as well as the servers on the outside side, on the outside network. This is all for this part. It seems that I need a fourth part number 4, to give you a small demo or snapshots about how hosts can access the various services. It's just a demo for proof of concept. Thank you very much. This is Hakim Adif. Bye.